In this session, I will be discussing the 12th part of multiple choice questions. This will be really useful for electrical science stream. So let us have a brief discussion individually. First question, the area under a unit impulse function is? It will be unity. If you calculate the area of unit impulse function, the result is unity. So let us define, before moving on further question, let us define what is a unit impulse function. So as you can see, so this is a graphical representation of an unit impulse function. You will be getting the output only when n is equal to 0. So whenever n is having other value, the output will be 0. Now let us define the function. Delta of n, that is the representation of impulse function or impulse signal. Delta n is equal to 1 where n equal to 0. So the rest of the point, n not equal to 0, that means output is equal to 0. That you can directly explain from the diagram. So I will be getting the output only when n equal to 0. So consider other point. Suppose if I take 1, then output is 0. If I take 2, then output will be 0. Then if I accept the value of n equal to minus 1, the output will be 0. If I accept the value of n is equal to minus 2, I will be getting 0 output. That's a peculiarity. So I can go for the area under unit impulse function is unity. Let me move on next question. A unit impulse signal has 0 value everywhere except at t equal to 0, where its magnitude is. Answer is unity. First option is the right answer. How it is possible? That means consider unit impulse signal. It will be having the output only when n equal to 0. For unit impulse signal, the output will be 1. Automatically, the magnitude equal to 1. So I can go for option A. So in place of unit impulse signal, if I put, you can look at the question, in place of unit impulse signal, if I put an impulse signal has 0 value everywhere except t equal to 0, where its magnitude is. At that time, if unit is not here, your answer will be infinity. You have to choose in that manner. You have to read the word very carefully. Now it is unit impulse signal. At that time, what will be the magnitude? It will be unity only, 1. But in place of unit, I removed unit here. Then an impulse signal. If you are having an impulse signal, then the result will be infinity. So what is the application of impulse signal? Defibrillator is one of the application which is used in biomedical field. So what is the importance of defibrillator? A defibrillator is a machine that sends a high energy electric shock through the heart. This high energy electric shock called defibrillation. The aim of this shock is to return a heart to its normal working state if it goes into cardiac arrest. That's a peculiarity of defibrillator. The main segment of defibrillator is the unit impulse signal. So that's a peculiarity. Now moving on to question number 3. Laplace transform of impulse function is. What is the Laplace transform of impulse function? L of delta of t, that is equal to 1. So you can go for option C. Moving on to 4th question. The system's impulse response is sometimes referred to as option A, weighing function of the system, option B, transfer function of the system, option C, transient response of the system, and option D, steady state response of the system. Definitely I can go for first option. That means the system impulse response is sometimes referred to as weighing function of the system. Now let me move on the 5th question. A large time constant corresponding to option A, sluggish system, option B, faster system, option C, overdamped system, and finally option D, underdamped system. Definitely, if you are maintaining high time constant or large time constant, your system response comes down. That means system is becoming slow. So I can go for first option, system is becoming a sluggish system. Now moving on to 6th question. Control systems are normally designed with a damping factor. So normally we prefer underdamped system. So for underdamped system, the value of theta will be less than 1. Now we can inspect different cases. Case 1, undamped system. For zeta value is equal to 0. Zeta is known as damping ratio. Damping ratio is nothing but actual damping to the critical damping. Now, if the value of zeta is less than 1, then it is becoming underdamped system. We prefer underdamped system. It's a normally used system. Then if the value of zeta equal to 1, then it becomes critically damped system. Suppose if the value of zeta greater than 1, then it is becoming overdamped system. These are the different cases. Based on the value of zeta, that means damping ratio or damping factor, we can define what type of system is that one. Okay. Moving on to 7th question. For a stable second order underdamped system, Pulsar, Which would be the right answer? Option A, purely imaginary. Option B, complex conjugate of each other. Option C, real and unequal. Option D, real and equal. So I can go for option number B, complex conjugate of each other. How it is possible? How can I justify? Now let us consider a second order system. The transfer function of second order system is given by C of s divided by R of s, that is equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square, where zeta is known as damping ratio and omega n is known as natural frequency of oscillation in terms of radian per second. Now let us consider underdamped system. For underdamped system, the value of zeta will be less than 1. That means 0, less than zeta, less than 1. Okay. Now what you can do is put the value of zeta which is less than 1. I'll be putting zeta is equal to 0.5. If I put zeta is equal to 0.5, the equation becomes s square plus omega ns plus omega n square equal to 0. By using the quadratic equation, I can compute the poles, how many number of poles are locating in that particular equation. So you have to equate the equation s square plus omega ns plus omega n square equal to 0. This equation is known as characteristics equation. From this I can able to calculate value of s. If I calculate the value of s, I will be getting minus omega n plus or minus square root of omega n square minus 4 omega n square divided by 2. By simplifying, I will be getting minus omega n plus or minus j root 3 omega n divided by 2. So I can justify option number B. That means complex conjugate of each other. Now moving on to question number 8. For a stable second order critically damped system, the poles are, which would be the right answer? I can go for option B, real and equal. Let us justify the particular answer. How I will be choosing option B? Now consider a critically damped system. I can put zeta equal to 1. Therefore, to calculate the pole, you can equate the characteristics equation. The characteristics equation that becomes s square plus 2 omega ns plus omega n square equal to 0. Here you have to put zeta equal to 1. That is why this equation becomes like this. From this I need to calculate the value of s. Okay, so if I calculate the value of s, I will be getting minus 2 omega n divided by 2. That is nothing but minus omega n. Therefore, I can go for option B. It will be real and unequal. I think it is very clear. Moving on to next question. For a stable second order undamped system, poles are, which would be the right answer? Purely imaginary, real and unequal, real and equal, then complex conjugate of each other. So I can go for purely imaginary. How can I justify this? So let us consider the third case. That means for undamped system, if zeta equal to 0, then it is known as undamped system. Now let us modify the equation, characteristic equation. That means s square plus 2 zeta omega ns plus omega n square equal to 0. This is known as characteristic equation. Now you can put zeta equal to 0. If I put zeta equal to 0, what should I get? S square equal to minus omega n square. From this I will be calculating s. That means square root of minus omega n square. That is nothing but plus or minus j omega n. That means it is purely imaginary. Then I can say that option A is the right answer. Now let me move on. Question number 10. For undamped system, the damping ratio is. So undamped systems are practically not existing. So what is undamped system? A system is said to be undamped if the value of zeta that is equal to 0. Then I can go for option A. So this is very important. I will be repeating again. For undamped system, zeta equal to 0. For underdamped system, zeta less than 1. This underdamped system is most preferable. Normally we are using underdamped system. Now third case, if a system is said to be critically damped, you can put zeta equal to 1. For a system is said to be overdamped system, value of zeta greater than 1. I have referred the textbook of control system written by Anand Kumar. If you are having any doubts, you can put up in the comment box. Now thank you for watching this video. Please share with your friends. For similar video, please subscribe this channel. If you are preparing for competitive examination, you can visit one more channel, that is Winners Capsule. Thank you for your continuous support.